this setcast video, we're going to be going over cross-site scripting, or XSS. XSS is a class of vulnerability where an attacker runs malicious code in the context of the client browser. Now this can be used to do things like accessing session cookies, making AJAX requests from a trusted source, their browser, or redirecting the user browser to a website controlled by the attacker. An interesting point to note is that XSS often directly attacks clients, so servers may not even notice that an attack is happening. Now these attacks can come in many forms, including directly injecting into the HTML, injecting into a JavaScript context, or even utilizing the templating language provided by a web framework, such as the GSP templates provided in Grails. OWASP has classified XSS as A3 on its list of top 10 web vulnerabilities in 2013. Now if we look at the hash of the URL on this page, we will notice that we have a script tag that generates an alert box between two button tags. The button tags, however, are in reverse order. This is because the first one escapes the button that we'll be injecting into, and the second one recreates it, so that the existing button tag becomes valid markup. Now clicking on the Switch to Spanish button generates the alert box that we have in the URL, meaning this page is vulnerable to XSS. We can run our JavaScript within the context of the client browser using an XSS attack. So looking at the code, we notice the JavaScript that handles button presses. We can see that it pulls directly from the location.hash without doing any escaping. Later, it also uses the HTML method of jQuery to write directly to the DOM without any escaping again. So this is how the code gets injected. In order to fix this, we should definitely escape the hash parameter when it's printed. In this case, replacing the HTML tag carets with their HTML escape components. This needs to be done even if the user is theoretically inputting to themselves. Another option is to replace the jQuery HTML method with a text method, which does this replacing for you, but it's still important to understand the difference and why we need to escape the code in general. So that was an overview of DOM-based cross-site scripting. Now let's take a look at JavaScript context cross-site scripting. So right now we're looking at the controller in Grails.env that prints out all the job listings in the system. One part of printing out these listings is to associate each listing in the table outputted to an individual listings page with more information. To do this, we create a map that associates the name and description of the listing with its ID and then pass it as a JSON string to the view. The view then parses this string and creates the table. If we take a look at the view, we'll see that we output the string as encode as raw. This tells Grails not to HTML encode the string, because doing so could mess with the JSON formatting. In case Grails decides to say escape a single quote, or braces, or something else, that would cause problems with the JSON syntax. If we take a look at what's actually outputted to the browser, however, we can notice the problem. If we look at the page source, we can see that the part of the JSON string outputted on the page was 2 braces. This means that if an attacker were to insert JSON specifically crafted to escape from those braces onto the page, they could inject JavaScript code directly into the JavaScript script tags, avoiding having to insert HTML tags. So again, this is another way to bypass XSS encoding. So how do we address this? We have to go back into our view and replace the encode as raw function with an encode as JavaScript function. This is a specific Grails function that uses a different form of encoding, better tailored towards JavaScript than HTML. It's always important to escape user input, no matter in which context it's found or where it comes from. So, the final type of XSS that we want to look at is templating XSS. In Grails, we use GSP template files, so we have to be careful for XSS with them. Here on our main listings page, we can see that it outputs all the listings from the database with a render function call onto the template. It's important to note that by default, Grails does HTML code all in values that are outputted to the template. However, if we look at this particular template, we'll notice that it uses the raw function call because the developer wanted to output Markdown to the template listings page. Unfortunately, this opens up a problem. If we go back to our controller, we'll notice that the controller does not convert the HTML from the database into an escape form before it converts it to Markdown. It simply converts it to Markdown straight out of the database. So if there was already HTML tags in the code pulled from the database, we'd be able to inject it onto the page. This causes DOM-based XSS. To prevent this, we're going to need to escape what comes out of the jobs listings database before we convert it to Markdown. Markdown does not in all cases strip HTML, so it's important to do it ourselves and not take the chance that we'll have a different Markdown parser. So we simply just create a new variable called listing safe and make sure to escape the HTML that comes from the database before we pass it to Markdown. This prevents the attacker from performing XSS and closes this security hole in our application. I'm Cyrus Malikpour. This has been another episode of SecCasts. Thank you for watching.